Let's talk about finding an inverse of that function. Let's talk about finding the inverse of this function and what it actually means to find an inverse of some function. The best way, does anybody remember how to do this or not? Anybody? Well, one of the easiest ways is to probably do this, is just change this to this temporarily. And we're going to solve this equation for x. So to solve for x, it's going to be this. And now we have to do this. You all see what I did? But I did this, and I moved this over here, and left this alone. Now this becomes this.
What about the 2?
So far, so good? Everybody see this? Everybody up with me? I just put these together and put this over here. Yes or no? Yeah.
Shouldn't it be 2xy? Or 2, yeah, 2xy minus x? You left out the 2 from the main problem.
What happened now?
The
You
2
gotta put a 2
in front of the x. On the original problem, you have x minus 4 over 2x plus 3. You didn't have the 2 in the on the right side.
What happened?
The 2x right there, you have y equals x minus
Where?
4 over 2x. Plus
Right here?
3. Yes, sir.
Right.
On the bottom. On the bottom. There you go.
You didn't put the 2 on the other side.
Oh yeah, right here.
I was starting to think you were trying to replace the 2 with a y. There we go, okay.
Okay, yeah. We got it now though, right? Everybody see that? I got too big a hurry, I guess. Actually, I changed this. It was going to be that when I walked in the door. When I walked in the door, it was going to be that. I changed it as I was writing it on the board.
Alright.
I guess I still was stuck on my head. So, is everybody with me so far? At this point, we can factor out an x. And you can put the y's first if you like. Put it around the other way. And now x is equal to minus 3y minus 4 divided by 2y minus 1. So far, so good? Everybody with me? So now, we now have this. We have that, right? Everybody see it? And all we have to do next is just change the values. We'll change all these. Instead of calling this y, we're going to, let's do this first. let's change all these. To that, and change, instead of making this y, we call it the inverse function. We could just make this a y, but we don't want to do that. We want to call it this instead, to let you know that it's not y, but it's what? It is an inverse function. Now, if you really took this one step or whatever, if this piece of paper was an x and y axis like this, and you had some function on this thing, and if you had, somebody says the other function drawn on this piece of paper is the inverse to it, you can always double check that by taking right across. Let me show you what I'm talking about. If this piece of paper was like this, okay, and somebody had drawn some function on it, and they drew us another function on the paper, and they said, how can you tell if they're inverses of each other? You could do so by folding the paper right across there. On the dotted line, fold that paper. In other words, fold this graph and hold it up to the light, and you would only see one line. That means they're inverses of each other. Does that make sense? Now, what does that actually mean in terms of making it real? It would be something like this. That's how you solve equations by the inverse function, right? I mean, if you solve this simple problem like this, how do you really solve that? What is a real method of solving that problem? That we all know that the simple shortcut way is what? Divide by 2. But the real method is what? Is you do the inverse function, which is this to both sides. That's really what you're doing. Because this becomes what? 2 to the 0 x, right? And 2 to the 0 is just 1. And this becomes what? Like that. That's really what you're doing. You're performing the inverse function. So the same would be true if you had an inverse function, then you could solve the problems with the inverse of it, okay? Just like the 2x equals 10, you were able to solve that by doing the inverse to the problem. Just like this, if we had this problem, this is y is e to the x. How in the world are you going to solve that equation for x? How do you possibly solve that equation for x if you know the value of y? If you knew that y was equal to 100, how are you going to go about solving that equation for x? You have to find something called what? An inverse function. So if you have someone give you an inverse function, then it may look like this. Does everybody see that? Can you picture putting a dotted line and folding that piece of paper and holding it up to the light? Can you picture doing that? What would you see? What would you see?
The lines would be on top of each other.
The lines would just be one solid line. So if that's the case, then this point must be, and this point would be what? Everybody see that? So if you folded that across this way and held it up to the light, you would only see one line. So now that you see that there's an inverse function to this one, and it's right there, then guess what? We will use the two inverses to do what? Solve for either one of them. If you knew that this was like this, I mean, how do you solve that? How do you solve an equation that looks like that? Or let's make it a little bit simpler than this. Let's make it like this. How about that? Just something fairly simple, not something very large. How do you do that problem? Anybody know how to do that problem?
Take the log or something?
Do what?
You take the log of 3.
Ouch. David, ouch.
I know it's
Anybody know how to solve that? How many of you would like to learn to solve that problem and any other problem like that ever? You only have to memorize one simple thing. One simple thing. And if you can do it, then it becomes what? A breeze. There's 2 keys on your calculator. And if they look like this, erase this away. Now the reason I'm doing this is because you see we found the inverse of this function, right? So because we found that we were able to get an inverse function, then that's going to allow us to do what? Do problems like this over here, okay? There are 2 keys, and one of them looks like this, and the other one looks like this. You all see those keys? Now, don't you ever forget this. The LOG with its looking something like this, it doesn't really matter or whatever, like that, okay? Its base is 10. Now, if they wanted it to be some other base other than 10, then they would have written that number right there. Some of you all are not paying attention. You won't ever learn to do this, ever. So pay attention. If this is another number other than blank, then it's that base. This is base 10. This will always, always, always be base E.
Just kidding. No, never mind.
Did you say base E?
No, I didn't, but I understand what you're saying.
Doesn't that all just equal Y?
What happened?
What I was gonna say was, is that because it's gonna be natural log
can't-
of x.
I can't hear you, I'm sorry.
Natural log of x is equal to log base e of x, which could just be equal to y, right?
Say that one more time, because I'm not sure what I heard what you said.
The base e logarithm of x is gonna be natural log of x is equal to log base e of x, or, oh god, yeah, of x equals y.
Which, yeah, I think what you said is correct,
Right. that's
if
what
I
was-
heard you correctly.
I'm pretty sure I'm right, I'm just like
Yeah.
double checking with what you're about to write.
Yeah, what, you will see in just a second or two, you all will see in a second or two what he just said. Listen, if you will learn to read this problem, you'll never miss another one. Ever, okay? If you learn to read this problem, you will never, ever miss another one, okay? So, this is logarithmic form, okay? So, we can write it in what we call exponential form, because this is logarithmic form, this is exponential form, okay? So if we can write them in terms of each other, we can solve the problem quite easily. Look at this problem right here. This is the way you read this logarithmic problem. You know, because there's not another number here, that it is base 10. What this says is 10. I'm gonna read this for you, okay? You don't read it as log x equals s. That's not the way you read it. The way you read this to work it is 10 raised to this power is equal to x. That's the way you read it. So we all know that 10 squared is 100. So now if you go back and you saw this, you know the answer is 2. You can actually punch log of 100 with your calculator and 2 will come back.
Okay, isn't it like if, say where the 2 is, if that was already a 10, wouldn't it just equal 1? Since
Wait
it's
a minute,
log base.
say that again?
Okay, since the formula is already log base 10, the base of it is already 10. If where the 2 is equals a 10, isn't the answer always going to be 1? Or am I wrong?
If this was 10?
Yeah, it always equals 1, right?
Oh, no.
Or if it's, I know if it's something, the answer is always 1, but I can't remember.
Hey, watch.
No, e is always 1.
Maybe that's what it is. E.
Now, it's what? So would you say 10, see this? 10 raised to what power is equal 10? 1.
Okay.
That's why this, look at this everybody. Do you know what the value of that is? Do you know what the value of that is?
1.
That is 1. Why is that 1?
They cancel out.
Because let me do this. I'll put a question mark out here. We know that this is always base e, right? So we're saying e raised to what power is equal to e. That's really what you're saying, because you found the inverse to that function. If you go back to this problem, how would you read this? You would say e raised to the third power is equal to x. And Lord knows I don't know what that is, but your calculator does. Your calculator can calculate that quite easily.
So, natural log of 0 would be undefined, right?
Tell me why. I won't make you answer that for me.
Okay, so.
What
because
else?
of the, because of
Take
the.
it one
because
more
of the-
step, Mr. Flowers.
Yeah.
Take
I
that,
was
take
gonna-
that one more step.
Right, I was gonna go with the infinity thing next, so negative infinity.
Right, yeah,
That's
okay,
where I
good,
was
yeah.
going.
Do you see why though?
Yeah,
Did anybody else see why, what he just said? Mr. Flowers, help me out here.
okay, so if you had a table on each side, you had X value, do you want me to come up there?
Yep,
Okay,
that's 0, right?
that's 0.
You can't ever get there.
Right.
Why not? Because this does
I will
what?
never touch 0.
It goes where?
Straight
It goes
down
to negative infinity,
when
and
will
it
touch
never
0.
does. That's why you cannot ever have ln of 0. Your calculator will throw up. Try it and see. Try to take the natural log of 0. Hurry. Quickly. Get off that computer.
I just have my hands
Take, what'd you get?
up.
ln of 0. ln of 0. See that? It threw up on you, didn't it? You did log of 0. Do ln of 0. What happens? What did it say?
Error.
Threw up. What'd yours say? Huh? Well, stop writing. Good grief, you writing too much.
Mine said error.
Of course it does. And what else, Mr. Flowers, can you say about this? Can't go there or
Or past.
nothing. Try to take the natural log of 9 minus 10. Do it again. ln of minus 10. Calculator's gonna throw up on you again. See there? Everybody see that? The reason why is because it's undefined. There's not.
Wait, so why would the natural logarithm of 1 be 0?
Right here.
Yeah, I got it, yeah. Okay, that was all.
Yeah, don't look.
Yeah, I should.
Don't you say that.
I got it.
ln, what's this? You're saying this. So what are you saying? Read this. You said e raised to what power equals what? E raised to what power equals what?
And then
Say it.
e raised to a certain power equals.
No. It's e raised to what power equals what? E raised to the 0 powers equal what? Does that not make sense? Did that answer your question?
Yeah. So then, well, you already answered that question. I was gonna say, so 0 raised to the power positive, which would just be any number. So it would be 0 raised to.
Just don't
all
raise.
number would be negative infinity.
What do you say?
Alright, never mind. I'll just stick in my own world back here.
Yeah, okay. I think what's important that you know is this. That if you took the natural log of a number less than 1, if you take the natural log of a number less than 1, or in other words like this, in other words, some number between what? 0 and 1, not including the 0 and not including the 1. Okay? if you took the log of, say, 0.5, you're going to get, there's 0.5 right there. You're gonna get a what?
Negative number.
You're gonna get a negative number. That make sense? Because take a look at this. What type of problem does that fit? What type of problem does that fit? What type of problem do you think that fits? Anybody got any idea of what type of problem that fits?
Something with time.
It's what?
Something with time.
Something with time, okay? Something with time involved. You all see the T. Can you recognize that this could be the amount with respect to time? Can you imagine that somebody has given you 500 milligrams of some type of medication,
Yeah, it's like, how
and
long-
over time it's going to do what?
Decrease.
It's going to decrease because it's going to look like this. When time is 0, that's 500. When time is 0, you got 500 milligrams. As time starts to do what? Click along, what happens to the medication in your system? I don't think it goes up, does it? What does the medicine do in your system? Does it not dissipate? It approaches 0. Eventually you would have, would you ever have 0 of the parts in your body? Not theoretically, because you'll never reach 0. The only reason it's unmeasurable is because you don't have a machine that critical enough to measure it. If you had a machine that would measure in the zillionths or whatever of a milligram, then you would always be able to measure some amount there. That is why that is why there's no absolute 0. Even in space, theoretically, the temperature should be absolute 0. Did you realize it's not? It is not. Why is it not absolute 0? Because there is some residual heat left over from the Big Bang. When the Big Bang occurred, there's residual temperature still left out there that accounts for that 0.7 degrees above absolute 0. Is what?
His phone is ringing.
They thought they would find absolute 0, but they didn't. It's not there. So.
Is that Kelvin you're measuring it
Huh?
in? Is that Kelvin that you're measuring
Yeah.
in? Oh, okay.
Yeah. About 273, Kevin. But as you can see, look at this problem. It's quite easy. I mean, it's like falling off a log. If someone said how much medication is in your system, if the time we're talking about is in hours, the time could be in what? Minutes, it could be in hours, it could be in what? Days, it could be in weeks, it could be in months, it could be in years. It all depends on what this rate is. If this rate of decay is measured in minutes, well then the time will be in minutes. If the rate of decay, which that's the rate, is measured in 5% per week or 5% per day, then the time will be in days. If that's 5% per second of a decay, then the time will certainly be in what? Seconds. So your time has to match whatever you're talking about. Does that make sense? If the rate is in months, okay? If the rate is in months, and they want to know how much is left after 2 years, then what would you replace T with? Certainly not 2, but what? 24. Everybody follow what I'm saying? So it's certainly dependent upon whatever the rate is that they're talking about. So if somebody gave you, said, okay, it's 5% per hour, how much medication would be in that person after 3 hours? Or let's say this, after 5 hours. How much medication would be in their system after 5 hours? You would just do what? You would replace T with what? 5, and then do the arithmetic with what? With your calculator. Just do it with your calculator. And you can do it from left to right if you've got the right kind of calculator. You can do it from left to right if you have the right calculator. Got it? Let me know if somebody else has got an answer. Anybody else get an answer? Let's see if David is correct. You got one?
I have 389.4.
How about you?
389.4.
289? That's close enough.
Yeah.
289? Anybody get 289? 389? Oh, I'm sorry. 389. Did you get 389?
No, I was telling you that's what he said. Cause you said 289.
What'd you get?
389.
That's what we got.
Did anybody not get that answer? I know a lot of you didn't get that answer, so. Did you get the
Oh,
three?
I cleared it already.
You already cleared it?
Mm.
You get it on yours?
I knew it.
You get it? My question now is,
389.
how much time must go by before the person has 250 milligrams in their system? Hey, sometimes I feel like I waste my breath. Make sure you bring your calculators to class, because I'm gonna start giving some pop quizzes, it looks like. I'm gonna have to, because I don't feel like teaching anymore. I really don't. Did anybody get an answer for that one? It's okay if you didn't, because we'll work through it. But I don't want to work through it until everybody wakes up, gets through their nap, and get the calculator out. And I'll work through it.
It's about 14 hours.
About 14 hours.
Yeah.
That sounds reasonable. So is what you're looking at, everybody, is this. You're looking at about where it's 250, right? Does that look okay? Is that reasonable? What I've got up there? When is it down to 250? So if that is the case, then you would do this. Does everybody see what I did? Anybody not see what I did? This happens to be 0.5. Okay? Everybody with me? Now, because of what I showed you a few minutes ago about the inverse properties, right? Where we found the inverse of the property of e to the t power, we found the inverse to be what? Natural log of t. Y'all remember seeing that a minute ago? We had this, e to the t, right? And this was what? ln x or whatever. Everybody see this? This could be ln x, this is e to the x, this is ln x. So they're inverses of each other. And because of that, we can use the inverse to solve this problem. So that means you have to do this to both sides. That's all that happens. And we saw a minute ago that this was what? That was 1. That is 1. So now the answer is ln 0.5 divided by minus 0.05 is equal to t. Remember what I told you about taking the log of a number less than 1, it is what? It is negative. So as the ln.5 is going to be negative, you're dividing a negative by a negative. That's how you get a what? A positive number for time. That makes y'all get an answer? You got 14, it was about
Yeah, 13.9.
13, what was that, 14? What I did over there is show you the reason why you have to find an inverse function, okay? That's the applications of inverse functions. Give you something, I guess, more in line with something like this. Suppose that you have this situation. This is not a pair of pants, you all. This is
in your pants.
Air ducts, and this is 6 inches, and this is 6 inches, and this is air ducts that air travels down through. And you have to be careful that you have what? The same airflow. If you have too big an opening here, too much air going here and not enough coming out down here, you're going to do what? You'll probably burn some motor up somewhere. You got to have it where it's forced air. My question is, how big should this opening be to accommodate that air handler?
How big are the
What should the diameter of this be to accommodate that air handler situation?
Can you tell us where to start?
Can you give us an idea? Cause I'm at 12.
Do what?
I said 12 feet.
But I don't know, right, that's too easy.
That's too easy.
I can tell you this, you would not get the job if you wrote 12. You would not get the job.
At least we considered, because we came up with an answer.
They would,
What
well,
about
they wouldn't
9?
either.
What about 9?
You wouldn't get the job.
Can we just get like a formula or something?
Hell, just make up your own.
Okay, that's what we asked, well,
Make up your own.
that's you.
Of course there's a formula. Just use it.
Can we have it?
Are we gonna use LN?
What?
Can we have the formula?
I hope you have it.
What is it?
If you don't know it, then you're in trouble.
We're dead. And none of us got the job. Hope my boobs get me the job.
Oh my god.
David, stop looking that up. That stuff y'all should know, really, truly. It's nothing magical.
Are we trying to get the area?
Do you all not see that the area of this has to be 18 pi? No?
No.
Dang.
How did you get that? Oh.
Come on, you all. What is the area of that?
6,
9 pi. What is the area of this?
9 pi.
9 pi. Y'all know what these two added together?
18 pi.
Well, how did you ever get that? I just don't understand how.
How'd you get
that
9?
became- Hell, I'm not telling you. That's a secret.
Let me get my glasses.
Yeah,
I'm
like,
tripping in the game
that
right
was,
Do y'all not see that's the answer?
now. No.
That you divide this side by pi?
I mean.
That goes away.
Definitely.
I don't even know how he got 9.
It's so simple. What's the square root of 18?
8.4.
How much?
4.24.
4.24?
You gotta multiply by 2.
4.25. 4.25 is equal what? 8.5 inches diameter. That was a simple, easy problem. Now go back and tell me why y'all have trouble doing it. I don't understand. I really don't.
I guess I don't know how.
Are y'all telling me that y'all don't remember the area of a circle?
Oh, yeah, that's how come you didn't know pi r squared.
Well, hell. Now it comes about, huh? So it's pi r squared. That, you know what? That one's pi r squared also.
Now
You may not know that, but it is.
do another one.
You know
You're
what?
ready.
And that one's the same as that one.
But you're already, now that you know.
So if you get this one, all you have to do is just double it.
Yeah.
So if you got it doubled, then you know what the area of this one has to be, which is what? And the area of that big hole is pi r squared.
Can you read that?
Same thing as the area of the little hole, pi r squared. So this is, the reason why you left it as pi is because the pi goes away, and then it's just the square root of 18, which is about 4 1/4. So 8.5 inches, anything over or under 8.5 inches is not going to be correct for the air handler. Did y'all not see that really?
No. Can you give us another one?
No.
Make up your own.
I guess I better take one off the test that I put on there, because y'all will never get it right. Really? I don't think you'll ever get it right.
Break that
Let's
one
give an
out.
example of it.
What?
Give us an example of it.
You just did.
I mean, we didn't have a clue. We'd been like A, B, C, or D.
Which one's closer to my answer choice?
Well, I got 16, so give it
Four of us closer to 16.
that not make you think, everybody? That make you think?
Definitely.
And y'all were looking at some formula? I mean, you already knew the formula, you all. Because it's what? You know the areas of the ends and how to get it, because I gave you the dimensions, right? So once you know that the area of one of them is 9 pi, the other one has to be 9 pi. Add them both together, that's 18 pi. So the area of the big opening has to be 18 pi square inches. But you know the area of the big one is what? Pi big R squared. This one down here, you could say this one is pi little r squared. Everybody see that? This one is pi big R squared, because you're talking about the big opening. That makes sense, everybody? See why you use the small r and the big R? Everybody okay with that? What is the volume of a sphere? Everybody remember? It is what? Remember that? That's the volume of a what? Of a sphere. Think of something here. Let's see. What if that radius is 5? What if that radius is 5? What is the volume? Okay, Bradley, Cicero's, Borland, Roberts, Smith, Sweetberg. You are
King.
Oh, I got you.
Is the answer 104?
166.75.
Is it 104.71?
What?
104.7?
Why don't we?
Yes, it is. 1.523.
4 times pi. 4 times 3. 5 squared equals 341. Oh, I got 3. 104.
No.
4. Make it a John.
That is a silver. It's pure silver, okay? I want you to smash it with a hammer, and I want you to make a rectangle out of it. And the width and the height of the rectangle is the same, but the length is twice as the width. The length is twice the width. The length and the width and the height is the same size. So tell me what size rectangle you've made out of that silver once you smushed it. Anybody not understand what I'm asking?
Hey, what did he say the lengths of the sides were?
Do what?
Or what did he say the lengths of the sides were? Or what did he say the lengths of the sides were?
The width and the height is the same size,
Okay.
and the length is twice as. Twice as.
Length is twice the width.
Anybody got it?
You're still gonna keep your same one. Wait, do you wanna know like how long like each side of the rectangle is?
Yeah, how big is the rectangle?
Using the same volume?
Yeah, using the volume that we got. And
Got it.
Yeah, I already gave you one silver spherical object. I only gave you one. I think it was 5 inches in radius, right?
Yes.
10 inches diameter. That should be an easy giveaway. That is an easy giveaway problem. Everybody got it? David, you got it?
I think, I feel less confident now.
Huh?
I feel less confident now, but, those are the dimensions.
What is it?
Those are the dimensions of the cube. The width and the height are gonna be 6.4, and then the length is 12.8.
Oh, okay. It may be. I don't know. I don't know the answer. Anybody got close? You get it? What'd you say the volume was over there?
I had got 103.
523.6.
Right, that close it up? Good enough?
I can see.
Everybody okay with that?
Yeah, that's what I got.
So you know, this has to be what?
Oh, to the third. I thought it said to the second, so mine was off.
Because I said that what?
I thought it said to the third.
This was what? I said the length was twice the width. And I said the width and the height were the same size. So this would make it what? The volume would be this, and this, and this. Yes or no? Am I right or wrong? It is this, and this, and this. This, and this, and this. Which says 524 cubic inches is equal to 2x cubed. If I divide by 2, I get 524 divided by 2 equals that, yes or no?
262.
Close enough.
Close enough?
Well, like, when we worked ours out, we got 523.6, and so you got 524, so ours.
Yeah, I got
is exactly
524.
close.
I did it in my head.
See, you're a little smarter than us.
Everybody get this? What did you get? 262?
262.
Oh, wait, yeah, cube roots.
Do you not see that you have to take the cube root of this side? You have to take the cube root of this side.
How do you do that?
What is the cube root of 262?
6.4.
6.4 what?
Inches.
No, inches.
Inches.
You
Why?
took the cube out. You
Because
just took the cube out.
the cube root of inches cubed is inches. So it is 6.4 times 6.4 times 12.8. That's the volume. That's the volume of the rectangle. It is the same as the volume of the sphere. Does anybody not see that? Time to go.